Alright, we made it to the last joint, joint D. If you're watching joint D before joint E, I'd go back and watch the joint E video because it shows you how to solve for the member DE, that 958 in compression. But when we get to joint D, we are going to draw that free body diagram again. That free body diagram is created by all of the different segments that interact at point D. So there's 1, 2, 3, 4 different ones. First one is the force of 1,000 pounds. Down in the y direction. Then we have the force of member AD, which we calculated back in video 1, where we've got the value of that being 1,379. We then calculated already what the two legs, or the two composite vectors in the x and y direction were, 975 and 975. So we're not going to do the work again with that 45-degree angle. We're going to plug in the force of member AD in the x direction is going to be 975, and the force of member ADY is going to be 975. So we calculated that from another work. We had it there. We're going to use it again because that same member interacts at that joint D. So the other thing we've got interacting at D is the member DE. Member DE applies compression, so it's going to go to the left in this case, and that we calculate is at 958. Then the last one, the unknown that we have right now, is the force of member BD. Force of member BD, we are going to assume tension, but we're not going to draw it there. We're going to assume it because we've learned a couple things, so we're just going to leave that segment itself. And we've got its two composite vectors. We've got the 56.31. Again, if you miss how to solve that 56.31, go back and look at video A. You've got 2, 3, so opposite is 3, adjacent is 2, so the inverse tan of 3 over 2 gave us that 56.31. We have its two composites. We have force of BD in the x direction. We have the force of BD in the y. So now, what do we've got? We've got the sum of all the forces in the y direction is equal to 0. So we've got one force in the y direction. That one is applying compression, so it's going up. We have the 1,000 pounds of force that's being applied and known from D. So therefore, we have one unknown force, the force of BD in the y. So that 975 going up needs to equal to that 1,000 going down. Well, the sum of all the forces going up needs to be equal to the sum of all the forces going down. So therefore, the force of BDY needs to be going in the up direction. How much force is being applied on member BD in the y direction? 25 pounds of force. So therefore, that is applying compression because it's going up to the joint D itself. So now, we've got to calculate the sum of all the forces in the x direction. We've got one force there. That one is applying compression, so it's going to the right. We have the 958 applying compression, so this one's going to the left from member DE. And now what's nice about this last one, since we've got everything else solved, we don't have to do trig to solve for that red right triangle. We can to show that they're both the same, but we've got 975 to the right, 958 to the left. We're subtracting those two. We get left with that 17 pounds of force of the force of member BD to the x. So we solve Pythagorean theorem. We've got 25 squared plus 17 squared equals the force of member BD squared. 25 squared plus 17 squared. We're going to take the square root of 914, or the square root of that answer, second, and then the equal sign. We get that force on member BD being 30 pounds of force. So again, if we wanted to, we could go ahead and do the trig for that. We can use those angles. We can set some different stuff up. But since we had the two sides, we went ahead and looked at just Pythagorean theorem. Here we can prove it. We've got the sine of 56.31 needs to equal to 25 over the force of BD. So I'll just do it the other way for you. Just for those that people want to see it, 25 divided by sine of 56.31 gives us, look at that, 30 pounds of force, just like we had predicted, just like how we use other formulas. fill that into our final document. Now we've got all our tension, we have all our compression, we have all the known forces of all the members of our truss. Congratulations.